Chapter 8, Quantities and Chemical Reactions. I skipped section 8.1. Right now I can't remember why I did that, but I'm sure it was for a good reason. So we're going right to section 8.2. And we're talking about making pancakes, and I'm sorry if you're hungry because you didn't have breakfast. So here's a new word for you. Stoichiometry. Let's see, it is the 11th, all day long. Stoichiometry. What does that mean? This is the numerical relationship between chemical quantities in a balanced chemical equation. So we've been talking a lot about balanced chemical equations and types of equations and what products form. Now we're going to look at the quantities. So we can predict the amount of the product that is formed based on the amount of reactants. And as you can imagine, this is a very useful thing. If I start out with X amount of reactant, I'm going to end up with Y amount of product. And if you're manufacturing things, you need to know this so that you know how much stuff to start with. So this is called stoichiometry, and these calculations are central to chemistry. So I'm telling you, this is one of the big topics, okay? This one is really, really important, okay? This is not like the calculating empirical formulas that you could blow off and be okay. If you blow this off, you're not going to be okay. So it's helpful to think about things that we have experience with in real life. So making pancakes. So here is an example recipe, and don't try that at home because it's missing some things. But a cup of flour plus 2 eggs plus half a teaspoon of baking powder would give you 5 pancakes. Okay, that is a lot like a chemical equation. Our ingredients are the reactants, the flour, the eggs, the baking powder. The product is pancakes. And there are numerical relationships, right? You need a particular amount of flour to make that many pancakes. And if you double the amount of all the ingredients, the reactants, then you're going to double the amount of product, right? So the recipe is like our chemical equation. It gives us the relationships. You need 2 eggs for every cup of flour. If we know how much stuff we're starting with, we can predict how many pancakes we could make. So if we have 2 eggs and we've got enough of everything else, we know that we could make 5 pancakes from that recipe. And so we can write this relationship as a ratio, or we could write it as an equality. So this is saying for every 2 eggs we can make 5 pancakes. We could also say 2 eggs equals 5 pancakes. Now, does that mean that 2 eggs are the same as 5 pancakes? No, it means in this process, having 2 eggs means we can make 5 pancakes. And so in that sense, they're equals. So that kind of looks like a conversion factor, doesn't it? Dimensional analysis coming back right now. What if we have 8 eggs and plenty of everything else? Because there's always something that you run out of when you're making things, right? What if you have 8 eggs? How many pancakes could you make? Well, the picture's telling us the answer, right? If we have 8 eggs, we could make 20 pancakes. Well, how could we figure that out? Well, remember we said that 2 eggs equals 5 pancakes. So 8 eggs, that G was being a G and an S at the same time. 8 eggs, we can use dimensional analysis and figure this out. We want to divide by eggs because that's the unit we want to go away, and we want to multiply by pancakes. And the relationship is 5 pancakes for every 2 eggs. See that? So now we've got 8 times 5 is 40 divided by 2 is 20. 20 pancakes. Everybody okay with that? Because you got to be okay with that. Because if you're not okay with that, it's just going to get worse. It's scary.
Right, that means something big is coming.
I'm just thinking about when I make pancakes for my kids, it's like, wow, yeah. They go through 20 pancakes no time flat.